Well, greetings, Mr. Kolazar's class. This section, Chem Video 13.3, is on atmospheric pressure. An idea of pressure is going to be the force per unit area. So one way to say that, per unit area, per unit is to divide, so pressure would be equal to force divided by area. And so we're going to look at how we can change that pressure either by affecting the force or the area pressing down on something. So an example here is, if you were to apply force over area to get your pressure, if you just had your standard shoe, we're just going to say this is somebody's shoe, it's pressing down equally on all parts. So the area is distributing that force for pressure. Now, if you had a high heel shoe on, good high heel, there would be a lot more force distributed in a smaller area to keep that pressure the same. So you'd have the same amount of pressure pushing down, but that force would be in a much smaller area. Maybe a better way to look at this is if somebody was to pinch you, like your little brother, niece, little sister, nephew, whoever it might be, if you get pinched, that, ouch, it kind of hurts a lot more because they applied a force, but it was over a very small area. So a lot of pressure got applied to your skin. So as we're going to start discussing this idea of what pressure is. So pressure, when we look at gases, pressure is the particles exert pressure when they collide with the walls of the container, and that's going to be our key part. Anytime the gas particles when they hit the wall, hit the container, that's when they apply pressure to it. And that's what we want to look into. Let's add this one in. So just add this into your notes. You can increase and decrease pressure by creating more or less collisions with the walls of the container. So the more collisions you can create, the more pressure you're going to have on that container. The less collisions, the less pressure. So to look at that just as an idea, if we were to have a container with particles moving and moving and moving around in it, if we were to look at that, we could actually go through and change some ideas. So if we wanted to increase a temperature, if this was to get warmer, particles move faster. Faster they're moving, more collisions. More collisions equals that more pressure. If we wanted to cool it down, particles moving slower, less movement, less collisions with the wall, less pressure. Or if we change the shape of the container, make it smaller, particles are colliding more and more and more pressure. If we make the container larger, gas particles will finally move around and continue to fill the whole space, but less collisions with the wall, so less pressure. So while we're working, we want to look at how we can either add more collisions or less collisions to change the pressure on our container. Now, atmospheric pressure is going to be a key one that we look at because atmospheric pressure is always around us. Remember, we'll talk about STP, standard temperature and pressure. That's at 1 atmosphere and 0 degrees Celsius. But at 1 atmosphere, when you're at sea level, is going to be when the most air pressure is pushing down upon you. Air pressure is caused by particles in the atmosphere colliding in all directions. The further you are down towards sea level, the more particles there are. Gravity is pulling more and more particles down because as gravity pulls them down, we just have a higher concentration of air particles. More of them pushing on you increases a higher pressure. The further up you go in the atmosphere, the less particles are pressing down upon you. So when we're looking at that, higher air pressure is at the low area. So higher air pressure is when you're down closer to sea level. You have more particles that are actually pushing down on you. If you go up in sea level, lower air pressure. So if we go up in sea level, there are less particles that are able to be breathed in because the density is much less with that air. So if you go up to like Invesco Stadium or at Mile High Stadium in Denver, Colorado at 5,280 feet, it's much harder to breathe, but then there's less air resistance, so it's much easier to either kick a football or throw a football or hit a baseball, things like that. So there's lower air pressure the higher up in altitude you go. If you get all the way up to Mount Everest, very little air up there. It's even difficult to boil water at a high temperature enough to actually cook food. So that's one of the survival tactics that they have to worry about. So how we measure air pressure? Measuring air pressure is with a barometer. Barometer was a device that was invented by Torricelli. And he did something that we can't do anymore because they're using mercury, and we can't have mercury in here anymore, so due to the cumulative toxin. But he took a closed end tube. So if you notice, there's no end on the bottom of the tube here. And what he did was actually took that tube of mercury, open end up to the top, and had a dish of mercury to put it in. So we had mercury in both parts there. And as he took and flipped this over to put it into the liquid, that there was a small amount of space that when it flipped over that mercury came out, and this is a vacuum up here. And that vacuum up here is just empty space. And so what will happen is that some of the mercury came out from the top, and what we have is the rest of mercury just down below. And this mercury, there's air pushing down from the atmosphere. So air pressure is pressing down and it's holding that mercury in place. And so depending on how much air pressure is pressing down on the mercury, it holds that in place, and we can actually measure this amount. So the atmospheric pressure pushes down and it keeps the rest of that mercury in the container. Sealed tube up top, this amount of mercury can actually change. It can either go up or down depending on the pressure being placed upon it. So it measures the atmospheric pressure. So we hear about things like high pressure and low pressure. This is key with weather. High pressure and low pressure. If we apply more pressure, so we get more pressure pushing down from the atmosphere, it's going to cause the mercury to rise higher. If we have low pressure pushing down, there's going to be less push and the mercury level is going to go down. So we can actually read where on the barometer we were at to measure the pressure. So this is key when it comes to measuring weather, is one of our ways the barometer is going to be used. We'll continue with pressure conversions for next section. Safe travels to everyone.